If delta G is negative, the forward reaction is spontaneous. You got to know that. Like, these are just must knows. If delta G is 0, the system is at equilibrium. It means it's going both ways at the same rate. If delta G is positive, the reaction is spontaneous in the reverse direction. So delta G is measuring the change in free energy. If it's negative, it means it gives it off. And a process that gives off free energy is one that will just naturally happen, like iron rusting. If it's positive, it means we put energy in, which means by definition, it will not be a spontaneous process. Now, spontaneity for some things is affected by temperature. Rusting is not. Rusting will always happen spontaneous. The rate might slow if it's cold, but it still rusts. But the group me question about the freezing of ice, whether that is a spontaneous or not, that delta G is temperature dependent. Okay, so I went over that, sounds like, right? Okay, so here's the math. And it's not, we've done this exact same math before. We have analogous to standard enthalpies of formation, which we did in chapter 5. It was the sum of the products minus the sum of the reactants. Yes? Say that louder. Yep, this means at standard temperature and pressure. All right. So these we get from tables. All right, for the individual parts. So delta G naught is equal to the sum of N, where N and M are the stoichiometric coefficients. That's an arrow of your reaction. So you have the sum of your stoichiometry or your moles times delta, your Gibbs free energy of formation for the products minus the sum of all that. It's a lot of words to say, but you just find them in a table. I promise we did this in chapter 5. In chapter 5, I believe we found delta S naught values. Wasn't it S in chapter 5? Delta H values, whoops, whatever. We found those. So this chapter, we're doing delta S and delta G. All right, this is an equation we must know. It's just plugging in from tabulated data. Not is not that important. It just means at specific, the standard conditions, which these are different. It's 1 atm and 0 degrees Celsius or 273 Kelvin. That's just in the table. Like it will tell you what they are. All right. Let me know when you're ready to go on. It's exactly the same process. And the H's. All the same. Oh, why are you doing this to me?
Yeah, he was calling it twin triangles yesterday.
Who was?
Darren.
And then Reese kept saying delta. I'm pretty sure it's changed.
I'm pretty sure you're annoying.
I support
That was rude.
only the first one.
All right, you're probably right. Okay, and the Zoom. Okay. Oh, hey, I just lied. This one is 25. What is the one that's at 0? That's probably the electricity one in chapter 20. I apologize. 21 or whatever. Yeah, we'll get there. This is fast. We're most of the way done here.
Oh, so that's what G actually equals. So that's what delta G actually is. That's what delta G actually equals.
Right here.
Yeah.
This is another way to calculate it. This is also another way to calculate it.
Oh, and that's probably the more important one.
So, well, they're both important. How would you find this one? You plug data in from a table. That's when you don't have, and it's at standard conditions, which means at, I guess, 25. I lied, I apologize. You can solve it for this if you have these values and the temperature.
on the test when it like asked for a certain temperature pressure, so like certain pressure is 118, but with temperature would it be 25 Celsius?
It's 25 C or 298 K. But there is one, and it has to be the last chapter, I guess. I thought it was this one where it's 0, and it's really stupid. 298.
Why is electricity at 0?
I can't remember. Because we usually spend 2 days on that, and it's been 2 years since I spent 2 days. Whew. Okay, this is really important here. Both of those equations are important, but you have to be able to solve delta G for both. And we don't really usually care about the value of delta G, we care about the sign of delta G. Okay, so the question here says, how does delta G change with temperature? So this is can be somewhat confusing.
Doesn't it become more negative because you've got it more spontaneous?
So more negative. I forgot something there. There we go. With a what? Higher temp. And what does more negative mean?
It means that it's more chaotic.
Okay, more chaotic, but more entropy, but more spontaneous. This is what we care about. Meaning, will it happen? And that's why, by the way, when we heat things, things happen because they become more spontaneous. So it's kind of dumb because we're really adding temperature, which means it wasn't spontaneous. But at that temperature, it will be. Like your cake mix, it doesn't just cook itself in your shelf. You put the stuff in, and it still won't cook itself. It'll just dry out. You have to do what? You add heat until the process becomes spontaneous, meaning it will happen. And then you cook.
Cooking isn't really cooking, it's just making things more.
Yeah, with the addition of heat.
I just never write that down. I had some spontaneous chicken. Chicken nuggets.
They'll make cookies. You still add heat. But that's more just of a thickening and then cooling process. Yes, Judah.
My question last night about water being spontaneous. I'm kind of confused on what spontaneous means. It doesn't mean immediate.
No, it just means under those conditions, which way will it go? So at 25 degrees Celsius, water will freeze. So we'd say it's spontaneous at 25. At 33, it won't. So we would say it's non-spontaneous. So I don't know the values off the top of my head, but we would do the math, and at 25, that's a percent. Whatever, at 25 degrees, we'd end up with the negative value.
So once it turns to ice, so is water freezing a reversible reaction?
Yeah, you just change the temperature. All right. So these can be tricky. There are two parts to the free energy equation, and they will very often talk about this. Don't think about this as a negative sign. That can get a tiny bit confusing. Delta H that's the enthalpy term, which can be positive or negative, right? All right, and then T delta S is the entropy term. Enthalpy is the heat required or given off. Entropy is the disorder of the stuff. So like a solid, low entropy, a gas, high entropy.
So entropy is disorder.
Uh-huh. The temperature dependence on free energy then comes from the entropy term. So we got a tricky thing coming here. It means this. It means in the equation, if I'm saying entropy depends on temperature, it's this piece. Ignore that for a minute. It's just this part that will actually determine how it changes on temperature. So we're going to come back and we're going to fix that sentence in a minute. because it's kind of true and kind of not true. Okay. All right. I think there's a little table coming up that summarizes it. Yep, right there. So here's what we have. This table really should be one you write out a few times and write over and over to practice it. So the effective temperature on the spontaneity of reactions. Well, I'll come back to this slide in a second. But we wrote this sentence a minute ago, and I didn't put a period because it's only half true. Look at this piece right here. Ignore all of this. This is T times delta S naught. You with me? We're in Kelvin, so T is always a positive value. Is S always a positive value? No. So what if this is a negative? Then this is a negative. And then what are we really doing? We're making it more positive. So in order for this sentence to be true, it becomes more negative with an increase in temperature. That's if delta S is, that's, see how tricky that is?
There's two parts to that.
There's definitely two parts. And that's what this table is going to try and tell you. It's going to try and show you that, hey, if this is a plus and that's a plus and that's a minus, then it does these three things or these things. It's really tricky. It would be nice if these were always positive values. But as they say in the 80s, homie, don't play that. All right, so here we go. If delta H is positive, delta S is positive, then that means this. Sorry, I don't know why I said that. That's a negative. It's definitely negative. I don't know why my voice said positive. If that's a negative, that's a positive, then this piece will always be a negative. You with me?
Yeah.
All right. That means delta G will always be a negative. So this set of conditions means that this will always be spontaneous no matter what the temperature is. The example here is that 2 ozones will always deplete to 3 oxygens. Yes, sir.
It says when S universe is positive and delta G is negative. Is that what this is?
This is what this is talking about. Okay. All right. When delta H is positive and delta S is negative, then this piece is positive and this piece is positive. That means it's non-spontaneous at all temperatures. No matter what math you did with this combination, the answer would always be a positive value.
So if you know that thing of delta G equals the delta H minus the delta, if that equation, if that's negative, you always go spontaneous.
Yep. This is just.
All you need to know is one piece of all 4 of those values.
No, you need to know 2. You need to know 2. And you don't have to memorize this piece. If you can do the process correctly every single time, and you know what a plus and minus means, you're good to go as well. All right. Here's where things get weird. It's when you have a negative negative and a positive positive. And then you have your, if this are both negative, that's a positive. They're both positive, that's a negative. You get either answer. And then that is when they are spontaneous based on their temperature. All right, let's sort of put this into English. And then actually, I don't know, sometimes this makes sense more. If it gives off heat and becomes more disordered, that's what nature likes to do. So that means it's spontaneous. Like every single time. That is a super spontaneous process. It meets both demands. If it requires energy Well, hey, that probably is not spontaneous, right? And delta S decreases. Well, that doesn't happen, right? My children have never once just randomly cleaned their room, ever. It's not, it is a non-spontaneous, it's a mom yelling at them 12 times and then me threatening some pain, and then it gets clean. All right? Not really, by the way. Okay. So then this is why it's tricky, because it gives off energy, but it reduces the disorder. And that's where it gets weird. And this is where it requires energy, but the disorder increases. And once again, so that's why these are a little bit tricky, because they do opposites of each other. Okay. And I know, okay. I know this is tricky. If we could go back in time and switch all the signs to make everything make sense in chemistry, it wouldn't even be a hard class. But we can't. It is a hard class. All right. All right. So here we go. Under, this is a pain in the butt, but it's fine. Under any conditions, standard or not standard, the free energy can also be found this way. So this is a third way to find it. Delta G is equal to G naught plus RT ln Q. I will undo this because this is important. It is the same value, but it has different units. Sorry, it's the same thing, but it's different units, so it's a different numerical value. What's that? That's a great question. I wish I was a math guy. I don't know. All right. So if the reason why this one is convenient is because it relates to things we've been doing for a month. It's Q. This is a constant. That's just temperature. And then I can calculate Q. Remember, Q is the conditions of a substance that may or may not be at equilibrium. It's the equilibrium expression, but you plug in the values that you're given, and it's not guaranteed to be at equilibrium.
Wait, how come we're trying to find delta G?
Well,
You know what delta G not is true?
yeah, these are standard, but we're trying to find out if it's spontaneous at the new conditions, not standard conditions. So this thing is crossed out. It's important, but you don't worry about memorizing it. So under standard conditions, all concentrations are 1. So Q equals 1 and ln of Q equals 0. So the last term drops out. So that's saying, hey, if we are at standard conditions here, then of course, this just goes to 0 because it's the ln of 1 is 0, and that makes this whole term just drop out. So under standard conditions, G and G naught are the same, which would sort of make sense because they're standard and standard. Okay, I know this is weird stuff, but it's just math, like almost everything we've always done. Q is the equilibrium expression. Like you're plugged in, it will say, hey, you have A, B, and C, and their concentrations at a specific time are 0.1, 0.3, and 0.05. So you'd have an equation, A plus B goes to C. So your equilibrium expression would be C raised to the first, which we don't usually type, A1, B1, and you plug those in. And that would be Q. Okay. All right. At equilibrium, Q equals K and delta G equals 0. Tell your partner what a delta G equaling 0 actually means. It's on the board. It means it's at equilibrium. It's a big circular argument, right? So if you ever do it and you get 0, don't think, oh no, it can't be 0. No, it means it's equilibrium. It can go both. It is going both forward and reverse. So both are spontaneous. All right. Rearranging this comes to this math, which kids get super wrong. But K, then you can solve for K. K is equal to E raised to the negative delta G naught over RT. Once again, 8 pi is how you should memorize that. Divided by RT. Yep. And it's all raised to it. K equals E raised to negative delta G naught. And this is divided by, the exponent is RT. Can I what? You don't need any of this. This is the derivation of all that stuff. So this is how we get back into knowing the equilibrium constant. From a whole different application of stuff, they still relate to each other. Now, every one of these equations I've given you are on the AP test, like the cheat sheet. So you don't have to have them memorized, but you have to know what you're doing. These are very tricky. They are. I don't think that they'll be on the test this year. I really don't think they will be. They usually are not in the first place. And then with COVID, they say they're going to test everything, but I'll be shocked if they test anything past chapter 14, to be honest with you. Well, chapter 15, chapter 15.
Do you really think so?
I do have that feeling. Yes. It's back to the format from the year before. Yep. Last year was the best year to take AP chemistry test. No, it was still all math, but it was only on chapters 1 through 10. 1 through 10 are not hard at all.
1 through 10 are easy.
It's usually 1 through 20, and they only do 1 through 10.
I'm just saying, didn't they say chapter 14, only everything 1 through 10?
Yeah.
They actually say that.
The way our book is, really, they went through chapter 13. All right, here we go. So it's time for practice. The Haber process has come back. The Haber process for the production of ammonia involves the equilibrium of that. So it gives you delta H, it gives you delta S. It gives you the equation. It says assume that delta H naught and delta S naught for this reaction do not change with temperature, which is false, but we don't care. It tells us not to worry about them changing. All right. Predict the direction in which delta G for this reaction changes with increasing temperature. Explain your prediction. Calculate the values of delta G for the reaction at 25, and I think there's a C. There is. It wants it at 25, and it wants it at 500, and that we'll see if that matches your prediction. Okay, so talk with your lab partners through how to do this problem for a few minutes, and then we'll work on it together. Temperature should always be in Kelvin because then there's not a negative temperature because there should not be. I thought he was a genius. Yep. So it wants A, that's writing. This is from an AP test. It wants you to predict and explain, and then B and C want you to prove it. You can get very large or very small or very negative numbers on these. Don't doubt yourself. Yeah, that's pretty cool. Scroll up again. Joules, Kelvin, and kilojoules. That's something you might want to notice. Oh,
Oh, I just saw the A's and the K's and it's the same thing.
Oh, wait, we would use the first delta G that we got, right?
they got a match.
The first equation
How would you make that match again?
No, not the first one.
with the product minus
No, it doesn't matter, but they need to be the same.
Okay, this is hard. How do we know which equation?
Well, what did I give you? Did I give you tabulated data for N2, H2, and NH3?
Oh, true. There's no table. Oh, gosh. Okay.
I just remember how to make kilojoules and joules.
Just move it 3 places.
So to make it kilojoules, the other way? It goes to the right? Oh, like that.
So this would be 92,380 joules, or this would be 0.1984 kilojoules.
So it's probably easier to work kilojoules.
I personally go to kilojoules just because that's what we're killing it. So now you should have 59 probably instead of 59,000.
Yeah, that looks a lot better.
Wait, it's 59? I got 33.
Okay, whatever. I don't know what number, but
The table data is only for the first equation.
yeah, if this problem gave you this and then told you N2 delta G naught equals number H2
right.
NH3.
You don't have the delta G of what the product
Yeah.
reactions are.
So you would have to have that. So this one is the T or the delta H and negative T delta S.
Okay.
All right, my prediction is right.
What?
So the N number wouldn't make a difference to you.
No, just they have to match and your answer can have a J or a KJ. It does not matter. Because they're both the same. All right, one more minute. Right, I didn't miss any negative sign there, correct? All right, let's talk through it. If you're not done, it's acceptable. But first off, A, predict the direction in which delta G for this reaction changes. So it wants to know what happens to this answer with increasing temperature. So as T goes up, what is happening to delta G? So you really have to look at what delta S is. Delta S is a negative value, right? What's a negative times a negative? Positive. So the answer will become more positive or less spontaneous as the temperature rises. We good with that? It's tricky. I'm aware of that. Okay. The rest, we just plug everything in now. So we have delta H naught, which it gave me. And remember, this is 298. Don't use that trash on me. 773. Whoops. Right? Okay. So I'm going to plug it in now. Delta H is negative 92.38 kilojoules minus temperature, which is 298 times, I'm going to convert that to joules. So I'm going to say negative 0.1984. Now, you don't have to type it all down there. I'm just trying to make sure you realize you do this math and then you subtract it from that answer. That's why I wrote it that way. And you ended up with what value? Negative 53? Okay, negative 33 point something. Okay, and that unit would be? Yep. So I could say, is this exothermic? You'd say yes. Right there, right? I could say, is it spontaneous? And you'd say yes. They're both negatives, but they do tell you two different things. Okay, when it was 500, you do the same thing. Negative 92.8, or sorry, oh gosh, 38 kilojoules minus 773, right? Times negative 0.1984. What is my problem today? And that is equal to what value? 60? That's all right. And that is a positive? Okay. Do you have to put a plus sign? No, I'm putting a plus sign to emphasize. This, at this temperature, it is not spontaneous. At this temperature, it was spontaneous. All right. Explain why a producer of ammonia would want to carry out this reaction at a cooler temperature then.
So you don't have so much.
It's more spontaneous.
Yes.
Okay.
You don't want the reverse reaction to happen.
All right, what that means is you make more product. Just more product. That's a perfect question because there should be an E and there isn't. Well, there's supposed to be. Here's E. It says, in reality, an ammonia producer carries this out at a high temperature. Why would they do that? No, because of speed. Just because this happens spontaneously doesn't mean it happens fast. Like rust, that doesn't happen fast. Spontaneous, but slow. So what the ammonia producers do is they sacrifice product to increase the speed. Because they don't want to wait 2 years for this process to happen. They want it to happen now. So they put it under a lot of pressure and a lot of temperature. They take advantage of Le Chatelier's principle to try and cancel out that the delta G is such a slow process.
Why would you want to make
So that we can eat. Ammonia is the most important thing probably food-wise on our planet. It is a fertilizer that helps us get way more food out of the ground than that piece of ground should grow. So yeah, we wouldn't have 8 billion people on this planet without fertilizer. The fertilizers change the world. They really do. Is that like the Green New Deal? Same thing? Sorry. You gonna be okay? You gonna be okay, Coop? I'm just kidding. Okay, here we go. Is this the same? Cooper, is this the same?
No, because there's a table.
There's a table.
I almost messed that up.
That's okay. Tables mean what?
It means that you use the first one.
You use the first one, the sums of the big old ugly summation things. Okay. So give it a shot. Calculate the standard enthalpy change for the reaction. Which one of these is enthalpy? It's delta H. What's the entropy then? Can you predict what letter C is going to ask you for? It's going to ask for delta G. Good, John. Delta G. So this is both equations. You have to use the table to find these. Then you use the, no. Yeah, get out of here. Just kidding. YDK? You don't know? I know. I know. I've never heard that either. I made that up. Yes, Judah. Let's get out of control here. Sum of products minus sum of reactants. So my products, and we must include coefficients if there is one. Does that help at all?
Oh, yes, it does, because you need and an M.
Okay, I guess I'll just help you. Oh, Nikes. What about it? No, my friend's father was super nervous about it, but I had no equity in anything. So I was like, well, whatever. My bank account is $42. I'll be okay. Okay, so it's delta H of the products. So the products is just ethanol. Oh, it is ethanol. I got that right. Whew, that was scary for some reason. So I have, and it's only one. So literally the only product. So I have the sum of negative 277.69. That's the only product. You with me? Minus the sum of the reactants. The plus button. I don't know. There is one, but I've never used it. I just add them. All right. This is very nice for delta H because these are zeros, right? Because they're in their elementary form. I'll still put them just to be annoying, but it'd be 2 times 0. You with me? Where'd the 2 come from? Whoops. Coefficients plus 2 times 0 plus, that takes care of these two. No coefficient on water. I'll still say 1 just for the emphasis, times negative 285. And there's a lot of stuff in there. I think I wrote it all correctly. And that equals what? 8.16. Nisha says yes. Be careful here. What unit is that? Kilojoules. I put it in bold. On the test, it's bold. It's to get your eyes like, oh, those are different. All right, these are kilojoules. You don't have to keep everything in kilojoules, but you got to keep it in one of them. So I would usually just choose that one. Yeah, I'm going to find B, and then I'm going to convert it to kilojoules at the end. I'm not going to do it now like I could, but I'm not going to. Delta S naught is the same process, but with those values. Bless you. Are we ready? This is gonna be a pain in the butt. All right, so it's the sum of all that. I don't really want to write it out. I'm just gonna write this out. So the sum of the products, there's just a 1 here, right? That was stupid. There's just a 1. So I'll do it for consistency. 1 times 160.7. You okay with that? And then it's minus the sum of 2 times 5.74 plus the sum of 2 times 130.6 plus 1 times 69.91. And I think that's everything. Did I do something wrong? Okay. Whoa, that was crazy. I'm going to check the time right as Mumford texted me. He's thinking about me.
Do you like
That's fine. Mumford has one haircut. It's just the length of the cut that changes. All right, anyone have an answer for me? Negative 181. Are you okay if I say negative 0.181 kilojoules? Good. Okay, now delta G, what? Okay, so delta G is delta H minus T delta S, right? So just plug it in. 8.16. That was a positive, right? I never asked. That was silly of me. Minus T, which is no T, 298 times negative 0.181, and you'll get an answer. And then it asks, and we'll pick it up right there. It asks for K. What'd you get? You're welcome.
it was like
52 positive. Okay.